There's a fantastic photo here from a listener. They don't have their name on it, but they've been to Loch Bora, and last night the Aurora Borealis was just stunning. And another photo, I think this is Rock of Dunamaze. I can see something like the Rock of Dunamaze in the background. Again, down in Laois, that far south, we don't usually get to enjoy such a display of the Northern Lights. So what's going on? Why is it so spectacular right now? Well, Seanie Morris is a member of the Midlands Astronomy Club, and he is the STEM Engagement Officer with Laois County Council. Seanie, good morning.
Good morning, Will. Happy Space Week to you as well.
And many happy returns. So, big picture, and this involves the sun, ultimately. What's happening?
The sun has been going through regular cycles since we began measuring these back since 1853. We're currently on cycle 25, and what the cycle shows is that the sun goes through a peak and a trough of its own activity roughly every 11 and a half to 12 years. We're now approaching that maximum due to peak around about during the course of 2025. And what that means is that the sun just has this kind of increase in energy coming out of it that manifests itself as a exceptional number of sunspots on the surface. Therefore, we're getting far more coronal mass ejections, or CMEs, and they are belching out far more charged energy in the solar wind, to which our Earth is in the way, if you like, when these get pushed out in our direction. And when that happens, our magnetosphere, which is kind of a magnetic bubble that helps protect us, it helps Earth retain its atmosphere, is doing its best to deflect most of this solar energy. But the odd time, they'll get in towards the poles, and that's where at polar regions, north and south magnetic pole, they'll often see aurora as a normal phenomenon during the course of at any one time. But as there is an increase in this 11 and a half year cycle, we get overwhelmed, and therefore there's far more energy getting into Earth's magnetic field, and it overwhelms it at greater distances further south from the north magnetic pole and further north from the south magnetic pole. And that's how we get to see the aurora this far south.
So it sounds like this bombardment should be easy to predict insofar as you can observe the sun and then imagine there's going to be a Northern Lights type display in different areas. But actually, from what I've read, it's very hard to say with certainty you're going to see the Northern Lights tonight, for instance.
That is true. Now, we can see optically when the sun is active because of the amount and size of sunspots on the surface. For example, if you had a sheet of welder's glass, strong welder's glass, I think the grade would be 13 or 14 EW, you could place that in front of your eyes to safely look at the sun without any magnification, and you will see a few little dark blemishes, little spots on the surface. That's how big these spots get during solar maximum. When we get the energy that's coming out from those, if there was a sudden burst from a flare or a CME, there are satellites between us, namely SOHO and the Parker Solar Probe. SOHO is the Solar Heliospheric Observatory. It's been there since 1996. And it gives us a heads-on warning when there's going to be an influx of material coming our way. That is really the only way we can safely predict that we may see aurora. There's no exact science to getting it, because these particles will travel at, at speeds of up to maybe 7 million kilometers an hour. But it's only from this great distance away that when it actually hits our magnetosphere, and we tell if the KP index, which is used to measure the severity of a geomagnetic storm, should we see aurora this far south. Now, these sunspots that have been belching out this material have been occurring regularly, and there's a grading system to tell us how severe those outbursts are. They go from B to C to M to X, X being the greatest, and in a scale of 1 to 20 on each. We've been getting far more X-class flares being fired out from the sun's surface through these sunspots and coronal mass ejections in Earth's direction. And that's why we're seeing far more aurora now. So it's kind of, it's a nice display, but it also heralds a little bit of a danger, because we could get so flummoxed with so much charged particles that some countries may have a weakening of their electrical grid, as in an overwhelming... Yes, that their transformers will shut off. Satellites, yes, in certain orbits, especially those that are in polar orbits going over the poles, they will go into safe mode from time to time when the warning comes from the SOHO satellite that watch out, you've got about 7 to 8, maybe 10 hours of a window in order to prepare for this blast that's coming your way. And when that happens, yes, satellites can go into protective mode. If need be, astronauts on the International Space Station can go into a far more radiation-hardened area of the station to protect themselves for the duration that they need to. And in worst-case scenarios, when we see an intense aurora here on Earth, aircraft will even be diverted away from those zones because they're much higher in the atmosphere, closer to where the radiation is occurring that's giving us this visual display.
For us here on terra firma, the other big variable in whether we see it, or indeed any sort of astronomical event, is the weather. And we were blessed last night with clear skies. How much longer are we likely to enjoy these conditions?
Well, the weather is favourable today and seems to appear to be favourable for tomorrow as well. But the prediction of whether we'll see aurora tonight is very hard. You only have maybe a few hours of a window to which you can see how intense the geomagnetic storm is that could indicate where we'll see aurora on Earth when darkness falls. There are many apps and websites that can show you this for free. The main instigator of all of these is the National Oceanographic and Atmospheric Association, or Administration, the NOAA. They do the world's monitoring of solar activity and geomagnetic activity here on the ground. And that's what will give us a window to say, well, it looks like we have such an intensity. KP indexes, if it's above 6, and it goes from 1 to 9, if it's above 6, we have an excellent chance of seeing some sort of aurora tonight. Whether that'll be something that you can see easily with your eyes or that your camera phone can pick up better, that'll depend when it actually hits. And you'll only know by going outside and seeing it. So for last night, I saw it myself, but I knew what I was looking for, and it looked like a summer haze all across the northern horizon. But on my camera phone, when I did a 3 or 4 second exposure, then I was getting out the heavier greens and the heavier reds and some of the spikes that were present in many
Nancy
photographs.
lives in Auburn Heights in Athlone, and that's a very well lit up area. But even with all of that light pollution, she was still able to capture a photo with a very distinctive red hue. So that speaks to just how strong it is, or else the quality of her camera indeed as well.
That's true. And the colour even will give you an indication on how high the aurora is. It starts from red, comes down to green, then it goes into the purples and then blues and whites. And the blues and whites are when it's down deep into the lower layers of our breathable atmosphere. Oh. And when you have that kind of colour, that's giving you a visual indication of just how strong that energy has come from the sun in order to produce that colour. It's like it's forcing oxygen and nitrogen atoms to behave like neon lights. They get energized, and then they want to give away that energy that they've just been forced to have. And when they do so, they emit it in a frequency that our eyes can see. And that's what the aurora is like. It's like turning oxygen and nitrogen into neon signs. And it lasts for as long as there's enough energy to produce that, which could last from 2 or 3 hours to maybe 1 or 2 days. So we could get lucky again tonight as soon as darkness falls after 7:30, 8 p.m., and you start getting the twilight waning away from you. Keep an eye towards that northern horizon, and we may see that glow pop up for us again.
Fingers crossed. I have a young fella who wants to see it every night, and it's always after he goes to sleep. 5 minutes last
Poor
night,
guy.
5 minutes. That's as long as he was asleep, and I could see it then out the window. There's
plenty of opportunity to see it. So go ahead. Yes, sir.
Yeah. Did you get straight A's in school?
I did not. Funny enough, in my leaving cert, the only A I got, it was in construction studies, and I didn't pursue anything in construction once I finished school. It was weird.
Well,
I was C's and B's.
Your science teacher should be proud.
Thank you so much.
Seanie Morris, take care.
Thank you very much, Will. Bye-bye.
Seanie Morris is a member of the Midlands Astronomy Club. He's also the STEM Engagement Officer with Laois County Council.